We'll solve the exercise 2 of class 9. So the first question of exercise 2 is which of the following expressions are polynomial in one variable and which are not? And it has mentioned the state reasons for the answer. So the first one is 4x to the power 2 minus 3x plus 7. So we have to find if the statement is polynomial in one variable or if not. So we can say this one is polynomial in one variable just because it has only one variable, that's an x, and there is x. So this is polynomial in one variable. So the first one is solved. Next, go for 2. The second is y to the power 2 plus under root 2. So for second one, it contains only one variable and it is also a polynomial. So it is also a polynomial along with one variable. Now go for third one. The third one is 3 to the under root t plus t under root 2. So we need to find whether it is a polynomial one variable or not. First we have to resolve it just because it has mentioned under root. Under root means negative power. So we can write it 3 just because it has under root 2. So it will mark it as to the power 1 by 2. Plus it has mentions t under root 2 just because we do not find polynomial of the statement. Here is one polynomial, that's mean it is one variable just which is t. So it is a one variable, but it is not a polynomial just because it should have a complete number of power. That means it should be a whole number or total number of power. Whether it has t to the power 1 by 2, that means not a whole number. This means of power. If there must be t to the power 2 or t to the power 3 or t to the power 10, whatever, but it means should be complete power. Then it would be polynomial. Whether it has not a whole power, that means it's not a polynomial, but it is a one variable just because it has one value of variable, that's the t. Okay, now go for the fourth one. The fourth one is y plus 2 by y. So first we need to resolve it just because in a fraction. So the answer will be y plus 2 to the power y minus 1 just because it has 1 by y. 2 into 1 by y. So 1 by y is y to the power minus 1. So now y plus 2 to the 2y to the power minus 1. So it has just one variable, that is y. So it is a one variable as well, but not a polynomial just because it also contains minus 1, which is not a whole number again. So the fifth one is x to the power 10 plus y to the power 3 plus t to the power 50. So it is a polynomial just because it has complete power of 10, complete power of 3, complete power of 50. But it's not a one variable just because it has three variables, x, y and t. It has three variables. So it is a polynomial but not a one variable just because x, y and t has three variables, 1, 2 and 3. So it is a polynomial but not a variable, one variable. Sorry, it is a polynomial, not variable. It's a one variable but not a polynomial. It is also one variable but not a polynomial. It is polynomial with one variable. It is polynomial with one variable. So we have find out which all are polynomial and variable, polynomial but not variable, and also which has given the reasons. So we have completed the question 1. Okay, now we go for the question number 2. The question number 2 is write the coefficients of x to the power in 2 in each of following. So which one? The statement first statement is 2 plus x to the power 2 plus x. So what we need to do, we need to find the coefficient of x to the power 2. In this statement, 2 x to the power 2 plus x, just because x to the power 2 into 1 equal x to the power 2. So it has, what is the constant on it? It is 1. So the answer is 1. Go for 2. The question 2 is 2 minus x to the power 2 plus x to the power 3. Write in a simple value, or you can say in a value of x to the power 2. 2 into minus 1 into x to the power 2 plus x to the power 3. We need to find the coefficients of x to the power 2 is minus 1, just because it has a hidden value of 1 and it mentioned minus. So the answer is minus 1. Now go for the third one. The third one is pi by 2 x to the power 2 plus x. So it is pi by 2 into x to the power 2 plus x. We need to find the coefficient of x to the power 2, which is pi by 2. So the answer is pi by 2. Okay. Now go for the fourth one. In the fourth one, it has mentioned into 2 into x minus 1. So we need to find the coefficient of x to the power 2, but there is nowhere x to the power 2. So that means there is a value of x to the power 2 is 0. So the coefficients of x to the power 2 is 0. So the answer is 0. Okay. Now go for the question number 3. The third one has mentioned, give one example each of the binomial of degree 5 and monomial of degree 100. So the first one is, we have to mention binomial of degree 35. So the binomial of degree 35, it should be, just because that degree, so x to the power 35, or you can say x having a degree of 35. We can mention any number over here. And if we talk about the mono, it was a bio, just because single one. So if we talk about bio, then the bio should be, if we take the same number, then it should be 100. So if it has a number along with the x, that means it has a coefficient, then the power will be monomial. It has not a coefficient more than 1, it is the binomial. Now move ahead for the question number 4. The question number 4 has mentioned, write the degree of each of the following polynomials. So we have to write down, we have to find out the degree. So the first one is 5x to the power 3 plus 4x to the power 2 plus 7 into x. So what we have to find? We have to find the degree. Degree means the power. It had the biggest power on this statement, it is 3. So the degree is 3. Statement 2, it has mentioned 4 minus y to the power 2. So the degree is 2. Now go for the third one. It has mentioned 5 to the power nothing minus 7. Nothing means 1. So the power is 1, or the degree is 1. Now go for the fourth one. The fourth one is just 3. We have to find out the degree. There is no value of x, y, and z. That's when the degree is 0. Okay. Let me go ahead or move for the fifth question number 5. Question number 5 mentioned, classify the following as linear, quadratic, and cubic polynomials. So now we will define the linear. This question second was quadratic, and the third was cubic polynomials. Linear means having power 1 Quadratic, quad means 2, and cube means 3. Line, quad, cube. So we understand linear, that's mean having 1, quadratic means 2, cubic means 3. And these are in terms of power. So we'll solve the statements. Statement 1 says x to the power 2 plus x. What it is? It is having 2 powers. That means 2 is quadratic. Quadratic. Statement 2. Statement 2 says x minus x to the power 3. So the maximum power is 3. So it is cubic, obviously, dimension 3. The third one is having y plus y to the power 2 plus 4. So it has mentioned y plus y to the power 2 plus 4, y plus 2 equal quadratic. Then go for 4. The fourth one, 1 plus x. Having 1 is called for linear. So now go for 5. The fifth one says 3t. T means power 1. It's also linear. Go for 6. 6 one is r to the power 2. 2, it says quadratic. Go for 7, the last one. 7, last one says x. 7x to the power 3. 3, it says cubic. I hope you understand the linear, quadratic, and cubic polynomials. So we have completed the exercise 2.1, and next video we will start with chapter 2.2.